The construction of an underwater tunnel is a challenging engineering process. In the first step, the route of the tunnel is determined and the submerged ground is analyzed. Afterwards, the tunneling process begins. This is done underwater with large machines or starting from the land side. In tunnel construction, special materials and seal systems are used to provide watertightness. The tunnel is completed by placing the building modules underwater and connecting them to each other. Finally, land connections are made and the tunnel is put into use after security tests. Ocean Farm, one of the largest and most advanced fish farms in the world, is a facility located on the sea and has the capacity to host 1.5 million salmon with a volume of 250 cubic meters. This huge facility aims to provide fish with a habitat closer to their natural habitat by using sea currents. Additionally, it is equipped with various innovative technologies for an environmentally friendly production process. Bridge construction consists of design, site preparation, construction of foundations, superstructure installations, paving and final finishing. First, engineers determine the type of bridge and its structural requirements. Then, the foundations are built solidly, especially if a bridge is being built over water, water-specific platforms are used. In the superstructure installation, the main structure of the bridge and the road surface are created and the flooring is placed. Barrage construction involves the creation of a structure built across rivers or streams to regulate water flow, prevent flooding, or store water for irrigation, energy generation, or recreational use. The process typically starts with detailed planning and design to determine the appropriate location, structure type, and materials based on the water conditions and surrounding environment. Excavation and foundation work follow, where concrete or steel is used to form the base of the barrage. The next phase includes constructing the dam structure itself, which may include sluice gates, spillways, and other control mechanisms. After the structure is in place, the water flow is tested and necessary adjustments are made. Finally, safety measures are implemented, and the barrage is fully operational for its intended use.
estimated life of bridges varies between 25 and 80 years depending on location and material. However, bridges may age 100 years. With proper maintenance and rehabilitation. Bridge maintenance consisting of a combination of structural health monitoring and testing. This is regulated in country-specific engineer standards and includes an ongoing monitoring every 3 to 6 months, a simple test or inspection every 2 to 3 years and a major inspection every 6 to 10 years. In Europe, the cost of maintenance is considerable and is higher in some countries than spending on new bridges. The lifetime of welded steel bridges can be significantly extended by aftertreatment of the weld transitions. This results in a potential high benefit, using existing bridges far beyond the planned lifetime. As the spans of cable-stayed bridges and suspension bridges increase in length, erection methods have progressively evolved to meet the demands of the design. One of the critical considerations in the design of long-span bridges is structural adequacy and stability in the temporary conditions that exist during construction. Selection of the most appropriate erection method is consequently a key issue for the engineer during the design stage and subsequently should be agreed with the contractor during implementation. One of the engineering branches that requires the most careful engineering is bridge engineering. Because bridges have been carrying tons of weight since they started to be used and millions of people use these bridges. Although the bridges, which were started to be built in very old times, were built by placing a piece of wood on the stream in the early days, these modern bridges began to be built with the development of technology and the increase in needs. Let's start the bridge construction, which is made by placing huge pieces in the water, with sheet piles. We wouldn't be lying if we said that sheet piles are like floodgates. Because these sheet piles with curtain structure hold water by acting as a barrier and thus allow excavation on dry ground. Even if water leaks from these structures, which prevent the leakage of water, the water is thrown out with the help of pumps. After the palpnas are placed, the cofferdams are next. And in these cofferdams, they resemble sheet piles. In the same way, they are water retention structures used to hold water and facilitate construction while a building is being built in a place where water passes. Cofferdams are built 30 to 50 centimeters higher than the water level. Thus, the cofferdams hold the water and the excavation is carried out by applying it on dry ground. Commercial fishing is the activity of catching fish and other seafood for commercial profit, mostly from wild fishing. It provides large quantities of food to many countries around the world, but those who practice it as an industry must follow the fish deep into the ocean, often under adverse conditions. Large-scale commercial fishing is also known as industrial fishing. Catch and release do not allow you to catch and reproduce more fish in the ecosystem. This practice provides an opportunity for an increasing number of anglers to engage in economic extraction and successful fishing. Commercial fishermen collect a wide variety of animals. But very few species support the majority of the world's fisheries. These species include herring, cod, anchovy, tuna, halibut, mullet, squid, shrimp, salmon, crab, lobster, oyster, and scallops. All but the last four provided a worldwide catch of over 1 million metric tons in 1999, along with herring and sardines. Many other species are hunted in smaller numbers. Fish cage farming is practiced all over the world. By keeping fish in cages and fishing pen, entire communities can share a body of water, while each farmer can tend to their own individual fish farm. Fishing cage and fishing barn farming is attractive to many because a large crop can be grown, tended and harvested in a small area. Because the fish are in a busy area, problems can be noticed and addressed quickly. Thanks to these fish cages, fishermen can catch tons of fish with a single trap. Crab has been a viable food source since Native Americans lived and hunted on the Delmarva Peninsula. Known for the Chesapeake Bay blue crabs, Callinectes sapidus, the Chesapeake Bay takes its name from the Susquehannock tribe word Kispayuk, meaning big water. Crab fishing is fishing that catches or raises crabs. True crabs account for 20% of all crustaceans caught and farmed worldwide, and about 1.4 million tons are consumed annually. The horse crab, Portunus trichiburculatus, accounts for a quarter of that total. Octopuses are not part of the regular diet anywhere in the world, but are a delicacy in many countries. About 350,000 metric tons of octopus are caught annually, and the actual numbers may be higher as fishing is often underreported. It is very enjoyable to watch the production processes of the octopuses brought to the factory after the octopuses were caught in the sea. Located on Bal-Rumayt Island in Abu Dhabi, the farm is a 5-minute boat ride from Reem Island. There are 58 different sized ponds, 36 of which are 1-hectare ponds and 17 are half-hectare ponds. Each half-acre pond contains up to 300,000 shrimp, and a 1-hectare pond contains more than 500,000 shrimp. Located on Bal-Rumayt Island in Abu Dhabi, the farm is a 5-minute boat ride from Reem Island. There are 58 different sized ponds, 36 of which are 1-hectare ponds and 17 are half-hectare ponds. Each half-acre pond contains up to 300,000 shrimp, And a 1-hectare pond contains more than 500,000 shrimp. Processing so many shrimps in the factory is quite amusing. The Three Gorges Dam is a hydroelectric dam built on the Yangtze River, located near Sanduping Town in Yiling District, Hubei Province, China. The Three Gorges Dam is the world's largest hydroelectric dam with a capacity of 22,500 megawatts. Employing 40,000 workers, the dam is the largest concrete structure in the world. After the heavy monsoons in 2020, the annual production of the dam reached approximately 112 TWh. Breaking the previous world record of approximately 103 TWh set by Itaipu Dam in 2016. The ship lift is finished and it started working at full capacity on June 4, 2012. Each main turbine has a capacity of 700 megawatts. There are a total of 5 floors at the intersection, which is nicknamed Spaghetti Junction in the world press. A total of 20 ramps were used to connect all these roads at the junction, where a person traveling at the top is 37 meters above the ground. Speaking about the intersection called Huangjuyuan, whose construction started in 2009, officials say that the intersection directs vehicles coming from 8 different directions in the right direction. Officials, who made statements to the country's official news agency Xinhua, state that this junction is extremely necessary in terms of connecting the city center, airport, intercity roads. In the city of Wuhan, Hubei Province, which is the center of the epidemic that emerged in China, a 1,000-bed hospital was put into service. The construction of which took 10 days. A giant structure emerged with the merging of prefabricated buildings. It is seen that a giant structure emerges from interconnected blocks with the merging of prefabricated structures. Traveling for 10 kilometers on a 6-lane highway located 20 meters below a lake near Shanghai is now possible, with the country's largest underwater tunnel opened in China after 4 years of work costing several billion euros. This work, realized in China, will be the country's longest underwater tunnel. The 6-lane highway, which runs under Lake Taihu near Shanghai, is exactly 10.79 kilometers and is the longest underwater highway in the country. It is about 3 kilometers shorter but wider than the Roifast tunnel in Norway. Most importantly, thanks to the use of new techniques to waterproof the tunnel and the use of formidable devices mobilized to dig up to 20 meters under the lake. The work took a relatively short period of 4 years to be finished. There are many bridges that China has built entirely with its own means. All of them are produced with great technology. The bridge, which contains many firsts in terms of construction technologies, is a milestone in the construction of the world's railway bridge. The main span of the bridge must be at least 900 meters in order to meet the passage requirements of a 100,000-ton container ship on the Yangtze River. Old technologies allowed 600 meters for maximum main span. In this regard, the Shanghai Suzhou Nantong Bridge has made a great breakthrough. The bridge, whose construction took 6 years, has a main span of 1,92 meters. The two-story bridge has a 6-lane highway on the upper floor and 4 railway lines on the lower floor. The chief engineer of the team that built the bridge, Yan Zhigong, stated that this structure, which has a 1,092-meter span, is the world's first bridge of its kind with a span of more than 1,000 meters. A number of scientific researches were carried out during the construction process of the bridge. Within the scope of the project, 65 patents were obtained and 14 new construction techniques were used in the project. In bridge construction technologies, first applications were made in 5 subjects. Wind turbines are essentially structures with simple carrier systems. In these structures, there are several important components that determine the load-bearing system and its dynamic properties. These, the foundation is the tower structure and the mass collected at the nacelle level. The distribution of mass and stiffness along the wind turbine carrier system is variable. This complicates the dynamic behavior, even if the carrier system itself is simple.
Troll A has a total height of 472 meters and a weight of 683,600 tons. The platform rests on a surface 303 meters below sea level. There is an elevator inside one of the slip-form concrete cylinder legs with in and out grooves. It takes about 9 minutes to reach the depths of the sea from the platform above the waves with this elevator. It is a mathematical combination of several conical cylinders over 1 meter thick, made of continuously cast, sliding mold, steel-reinforced concrete, each expanding at the bottom and in the air. Concrete feet must be able to withstand intense pressure, so they are built with the continuous casting method, in which a 5 centimeters casting takes 20 minutes. The construction of the foundation of Troll A by Norwegian contractors on behalf of Norsk Shell started in July 1991 with a budget of $650 million. The foundation and deck sections are built separately. The joining process was carried out after the foundation part was partially immersed. This bridge is a 55-kilometer, 34-mile bridge tunnel system consisting of a series of 3 cable bridges, an undersea tunnel, and 4 artificial islands. It is both the world's longest sea crossing and the world's longest offshore fixed link. It was designed to last 120 years and cost $18.8 billion to build. Construction of the Hong Kong portion of the project began in December 2011 after a delay caused by a legal challenge regarding the environmental impact of the bridge. The last bridge tower was erected on June 2, 2016, the last flattened element of the 4,860-meter, 15,940 feet, straight section of the submarine tunnel was installed on July 12, 2016. Caissons are deep foundations that are typically dug or submerged to reach solid bedrock. They provide structural integrity, water resistance, underground maintenance capabilities, pumping, and more. Caisson foundations are waterproof structures made of wood, steel, and reinforced concrete, which are built together with excavation for the foundations of pier, bridge, and quay structures, among other things. They are temporary structures built to keep water out of the execution area. This allows construction to be done on dry surfaces. It is a temporary enclosure consisting of vertical or horizontal cladding with internal supports. Probably the most common type of all cofferdams because it is relatively economical when used to exclude shallow water, soil, or both. As offshore wind farms proliferate globally and capacity increases, a more sustainable future is clear. But building and operating offshore wind farms comes with its own set of challenges, from properly surveying the seafloor to building floating foundations in deep water. But this is how wind farms are built at sea thanks to these machines. It's really fun to watch. Breakwater is the artificial protective barrier constructed to enclose harbors and to keep the harbor waters undisturbed by the effect of heavy and strong sea waves. Breakwater enables the use of the enclosed area as a safe anchorage for ships and facilitates cargo loading in comparatively calm waters. This is the simplest type and is constructed by pitching or dumping rubble stones into the sea till the heap or mound emerges out of the water, the mound being composited, and the action of waves regulates its side slopes. An oil rig, offshore platform, or oil and/or gas production platform is a large structure with oil and gas extraction and processing facilities located in rock formations below the seafloor. Many oil rigs will also include facilities to house the workforce, although it is common to have a separate accommodation platform bridge connected to the production platform. Most commonly, oil platforms operate on the continental shelf, but they can also be used in lakes, coastal waters, and inland seas. It can operate in water depths of up to 3,000 meters, 9,800 feet. In shallower waters, mobile units are anchored to the seafloor. The Moss Wall is a barrier system that will close the openings in the Venetian Lake. The Moss Wall, which is a very difficult, costly, and very challenging project to build, is a system found by engineers to stop the flood currents in Venice. These 3 bays of Venice, which are open to the sea, will be immersed in the seabed by constructing 78 steel gates, each of which is 30 times 20 times 5 meters and 350 tons. When the sea begins to swell, the water inside the gates will be pressed out and the gates will rise to the sea surface. The Dutch nonprofit Ocean Cleanup, which develops advanced technologies to deplasticize the world's oceans, has brought the first batch of ocean plastic ashore after its first missions in the Great Pacific Garbage Patch. The world's largest accumulation of plastic waste covers an area of 1.6 million square kilometers. The entire fleet of passive collection systems is expected to remove 50% of the Great Pacific Garbage Patch every 5 years.
Hello to all of you guys. In today's world, technology has developed a lot. That's why there are so many giant projects. The engineers went crazy. Besides the best engineering marvels, you can also see giant machines. You will fall in love while watching these viral videos. You can also find a lot of new stuff. If you want more such videos to come, you can support us by liking this video. So let's start. Bridge engineering is one of the fields that require the most careful engineering. Bridges constitute a very important place in today's transportation. Their numbers are increasing at this rate every year. Designers, architects and engineers are needed in the construction of a bridge. The task of the engineers is some calculations and arrangements. The effects of the bridges on the ground, the strength of the ropes holding the bridge by tension, the properties of the products and materials to be used are asked from the engineers. In addition, engineers calculate the durability or survivability of the bridge in terms of load and damage. This stands out as the most important thing to do for suspension bridges. Bosphorus bridges are found in certain regions in the world, in certain times. And many people use these bridges for transportation. Its roots in history go back to before Christ. These questions can often appear in the minds of people who use it. How are Bosphorus bridges built? Isn't it hard to build on top of these straits? Let's examine these issues together. The most important part of the Bosphorus bridges is the part called sheet pile. These sheet piles, made in the form of curtains, prevent the water from filling the foundation pit open from the side walls on the ground. Even if the water leaks, it is a negligible situation as it is left downstream with the help of pumps. These planks can be wood, reinforced concrete or steel. Reinforced concrete and steel are used in most of today's bridges. These sheet piles are driven into the ground with the help of cranes. Basically, caisson foundations are used. These structures, known as floating caisson and floating chests, are prepared out of water and filled with hard materials so that they can sink to the bottom. Afterwards, they are buried in designated areas until they reach a solid ground. Corrosion occurs in the parts of concrete and iron used in bridges, especially in water. In order to prevent this corrosion from damaging the bridge over time, the bridge is strengthened at certain intervals. Strengthening and repairing bridges is the same in many respects. For example, the sequence of work done when repairing a damage in the column in the bridge, breaking the damaged place, exposing the irons, cleaning the irons mechanically and applying anti-corrosion epoxy on it. Afterwards, the necessary fibrous repair mortar is used to bring the column back to the same geometric shape.